KV Mahalakshmi, working as an assistant professor in the Department of Computer Science and Engineering in B.V. Raju Institute of Technology, Nasapo. Today we are going to see a topic of database design in database management system. So what is database design? So database design is we are going to organize the data based on the database model. There will be several types of model we are having. So based on that model, we are going to organize the data. So in that, what the designer is going to determine is what data must be stored. So what are the data must be stored, how the each and every data is interrelated to each other. So first thing is you are going to organize the data based on the database model. Second thing, what we are going to determine, the designer determines what data must be stored and how the elements are interrelated or the data are interrelated. So based on that, we have to fit the data to the database model. So based on that only, we have to fit the data according to the database model. So database management system manages the data accordingly. So what is the work of database management system? It will organize or it will manage the data according to the database model. So this is the work of database design. So you're going to organize the data based on the data model. So what you're going to do? We must know what data must be stored, how the data are interrelated to each other. Next thing. So what are the types of database design? So what are the types of database designs we are having? Hierarchical data model, network model, object-based model, relational model, entity relationship model, semi-structured model. So these are all the types of database design we are having. Hierarchical database model, network model, object-based model, relational model, entity relationship model, semi-structured model. So we are going to see each and every model one by one in a brief. First thing, hierarchical model. So by the name itself, we can understand hierarchical. Hierarchical means it will be following some hereditary. So first we will be having some root. So this is called root node, followed by their children. So these are all the child node. Then this child node will have some another children. So it will goes like in tree format. So root node, then child node, then child node. So it will be expanding the data, or we are going to expand the data in the format of tree. So that's why they given organizes the data into a tree structure. It is going to organize the data in the form of tree structure. It consists of root node. It consists of root node where each node is having a parent record and many child. For example, if we take here in this example we are going to take. This is our root node. We can take it as one table. In the table, we are having student ID, student name, and age. So we are given 66, Muskan 20, we have given, and 44, John 20. So student ID, student name, then age. So next we are going to insert the values of the particular student who registered this particular course and course name. So that's why we can say it is course ID and course name. A student can register, a single student can register many courses. Additional courses, we can register any number of courses. That's why we are given single student. This is one student. This student is registering this Python. Same. There's another one student, Alex is there. He is going to register Java and C++. Next, John. So he is going to register C++. with this course ID. So the data will be stored in the format of, or it will be organized in the format of tree structure. So first is root, next is child, then this child node will have another child. So this will be shown in the format of tree-like structure, like hierarchical order. Next one is network model. By the name itself, we can know network means it will be interrelated to each other. So instead of following the tree structure, we are going to follow graph. So that is called graph rather than tree. So what you're going to do, previously we will have one root. In that root will be there. So in that root we'll have the child node. The child node will have another child. So it will be follow some specific order. But here one child or two or three childs will be there. So this child will be having more than one. These three childs will have one parent. So previously, what you are going to do, more number of parents, n number of parents we can take. For example, here we are going to take project. Project is our root. So project 1, project 2 is a child of this project. So this department A, department B, department C is the children of this particular project. So this we are going to have, these departments will have 2 projects. So we are going to assign for 2 children we have, for any children we can, for example, we can take simply for one child we have 2 parents, 2 or more parents. So that is that is the use of graph. So here we can see project 1 is assigned to department A, department B, department C. Then in the project 2 is you are going to have with what? Department B, department C. So it will be having more number of parents instead of having only one single parent. So that is the use of network model. Tree is, there will be one parent for n number of children. Here a child can have more number of parents. That is the use of graph. So this is most probably used model before the introduction of relational data model. That is a relation before the use of, this is widely used model before the relational database model. Next one is object-based model. Object-based model is, here each and every thing or each and every data here we are going to store is stored in the form of objects. So objects are called as real world entities. What are the real world entities? Here we are taking student as one and entity, department is one entity. These things are called as attributes, or these are all called the classes or objects. So these are called as the objects of this particular entities. So each and every data here we are going to store in the form of objects. All attributes we are going to take, it's called, simply we can say it as that is an object of that particular entity. So this is the use of object-based model. All we are going to treat as an objects. Next, relational data model. Relational data model is mostly probably using, now we are using this relational data model. So this is widely used data model. So it will have, this is called as collection of 2-dimensional interrelated tables are known as relations. Relations are also called as table name. So relations is called as table. So here in table we are going to consider tuples and columns. So column is called as attributes, or fields are called as fields. Tuples are called as rows or called as records. So, which attribute is uniquely identified in the table, which attribute is used, or which attribute is used to find the tuple uniquely, then it is called as primary key. Here in this example, if we can take student as a relation, student table. So here the student table. So name of the table is student. So here we are going to take a roll number, name, roll number, then name, then CGPA. Here the roll number is there. So this roll number is used uniquely for each and every student. Each student will have unique roll number. So that is why it is called as a primary key. It should not have any duplicate values. When it is called as, then that particular attribute is called as primary key. So these roll number, name and CGPA is generally called as attributes or fields or columns. Column name. Here, this 101, Viber 9.1, these are called as tuples or records or rows. So, which attribute we are going to define primary key, that is mainly used to find the tuple. That is mainly used to find the tuple uniquely. Uniquely means it should not have any null values. It should not have. Primary key main thing is no, not null, plus unique. So this is the main criteria for considering the primary key. It should not have null values and it should be unique. Unique means it should be unique for there should be no duplication. Simply we can say this, there should not be any duplication. So when this attribute is defined like that, when it is assigned like that, when that particular tuple is unique and it should not be dull, then that particular attribute is called as unique or primary key attribute. Next model is semi-structured data model. Semi-structured, by the name itself we can understand it does not have any tabular form structure. It doesn't follow any tabular like form structure, but the data will be stored in some form of structure. So it will follow some structure but not followed by a tabular form. So here it is using their own tag like HTML. Here we are using our XML language. So XML. So what is that? Here this notice one. Here that notice one tag. We are going to close that now. To whom you are going. This to is also one of the tag. From, heading, body. So these are all the user defined tags. But it follows some structure. You can say it as our email. Simple, our email is one of the example of semi-structured. It doesn't follow any data. It doesn't follow any structured data format like table. But it follows some structure. So that is called a semi-structured data model. Here we are using some user-defined tags, but not tabular form. So that is called a semi-structured data model. Next one is important thing is entity relationship model. Entity relationship model is one of the highest level of data model. So here you are going to define the data, each and every data, and what is the relationship between each data. Here we are going to consider each data as an entity. Then we are going to consider about attributes and the types of attributes. What are the relationship among the entities? So these are the things we are going to see in entity relationship model. So this is one of the highest level of data model. This is one of the highest level of data model. It is used to define the data elements and relationship for a specified system. Suppose for a particular system, for any special system, we are going to design. For that, we are going to represent the data in a higher level. To follow that one, we are using this entity relationship model. So it defines the conceptual design of the database. Very simply, we can easy to design view of the data. Simply, we can use easy or simple. We can design the view of the data. So main thing is in the database structure is portrayed as a diagram. So this database structure is portrayed in entity relationship. So what is entity? What is an attribute? What is the use of an entity? What is the types of an attribute? What are the types of relationship? What are the degree of attributes you are having? Or what is the degree of relationship? So these are all things you are going to see in this entity relationship model. First thing. So here we are taking the student. Student is one of the entities. So entity can be any place or object. So it can be any class. So here we are taking, this is the student. This student normally we can say it as a relation. Suppose we have taken previous example relational model. We have taken student table. So that student table name is there. No? So that here we are representing the table name as an entity. So this student is one of the entity. the student have this attributes. What are the attributes we can, student table can have? Their roll number, their name, their address, their ID, their age. So these are the attributes for that particular entity. Simply we can say for a particular table, what are the attributes or what are the column names we are having? That column names here we are termed as an attribute. Here we are termed as an entity. Then attributes. What is an attribute? Attributes are names, address, ID, then age. These are all the attributes. Simply we can say it as a property of an entity. What is the entity here? Student. What is the property of an entity? The student entity is having name, address, ID, age. These are all the attributes. So here we are going to see the detail of what is the entity, what are the types of attributes. Next we are going to see about components of ER diagram. So components means here entity, attributes, then relations. So entity, what type of entity we are having, whether it is a weak entity or strong entity. What are types of attributes we are having? Key attribute, composite attribute, multi-valued attribute, derived attribute, one-to-one. In the relation we are going to see about one-to-one, one-to-many, many-to-one, many-to-many. So based upon this entity and attributes, we are going to design an ER diagram. So how we are going to consider this? It should have this entity, it should have their own attributes, and relationship between the entity and attribute is called relation. So these are all the types of relations. Next one is symbols, because you are going to represent the data, or you are going to show the data in a diagrammatic form. So here we are going to use some symbols to represent the particular entity or what are the types of attributes. So what is the relations? How we are going to represent that? So these are all the symbols we are using. If you are using rectangle box, that is called to represent the entities. Rectangle box is used to represent the entity. Ellipse is mainly used to represent the attributes. Diamond symbol is mainly used for relationship entities. What is the relationship between the two entities? So between two entities we are going to use some relationship. So that is called as relationship entities. Next, line. A line is what is a relationship, how we are going to define the relationships between the two entities. So we are going to represent some lines. So double ellipse means used to represent the multi-valued. So one attributes will have n number of values. So at the time we are going to use multi-valued attributes that will be represented in double ellipse. Next, double rectangle. Double rectangle is mainly used for weak entity. So these will be seen later in upcoming slides in detail. So next we are going to see about what is an entity. So previously I have little bit explanation I have given. So entity means what is an object or class or person or place, whatever may be. So that is called an entity. Here, what are the entities we are having? Here, employee is one of the entity and department is one entity. So this particular employee will works in the department. So this works for the employee works for this particular department. Then it is this works for, then it is called as a relation. What is the relationship between this employee and the department? This works for. Anyway, one faculty have to work for the department. So that work for, that is called as relation. That relation we are going to define here, or we are going to represent in the form of diamond. So diamond symbol mainly used to represent the relations. So hope you have cleared with it. So employee, what is employee, what is department? Employee and department are the place or object or person, bottom, class, whatever may be. So mainly we are saying simply we can say it as this is a table name. So employee is one table, department one table. What is the relationship between these two tables? So mainly it is used for works for relation. So employee works for this department. So this is called entity. Next, weak entity. So what is the what is the use of this weak entity, or why we are defining weak entity? Weak entity is an entity. First we have to clear about strong entity. Strong entity which have primary key. So entity which PK means primary key. Entity with primary key is called strong entity, and entity without primary key is called weak entity. An entity which depends on another entity is also called as weak entity. So here if you're having any primary key, so that is called a strong entity. So if you are not having any primary key in that particular attribute, so particular entity, so that is called as weak entity. So here we are going to take this example, loan and installment. Loan is one entity, installment is one entity. So loan is one entity, installment is one entity. So here this installment is always depends on this loan. Based on the loan only, how much installment and what are the number of installments you have to get. So always is this installment will be depend on this loan. So here this installment will become weak entity. So one entity depends on another entity, then we can simply say it is that is weak entity. So when it is called as weak entity. Next one is attribute. So attribute is, previously I have given explanation. Describe the property of an entity. Student is there, this student is entity, this ID, phone number, name, this age is called as attributes. So here this ID, so this ID, phone number, age, name, these are called as attributes. So simply we can say it as property of the student entity. So when it is called as a property of an entity, that is called as an attribute. So the table which have these attributes are called as an attribute. Key attribute. Key attribute is called, mainly we are using for main characteristics of an entity. Say same example we can take in the student entity. This ID, or we can say it as which entity is having the primary key attribute, that is called as a key attribute. Entity which having the primary key attribute, that is called as an key attribute. Key means which is used to find the data uniquely. So when it is defined like that, you have to give some underlined. If you are defining that attribute with underlined, then it is called as a key attribute. Next one is composite. Composite means many other attributes is associated with one attribute. Here we can take it as name is one attribute. So name, in that name you will be having first name, middle name, last name. So name is one attribute which have and then many other attributes. So this is called as a composite attribute. So composite means one, it is one is main attribute, another things are sub attributes for that main attribute. So name is simply we can say it as a main attribute. In the name we will be having some other attributes associated with that main attribute. So this first name, middle name, last name, these are all called as an composite attributes. Next one is multi-valued attributes. Multi-valued means there can be an attribute which is having or which holds a number of values, more than one values, then it is called as an more than one values. When an attribute is having more than one value, then it is called as a multi-valued attribute. Multi-valued attribute is always represented in double oval, always represented in double oval or double ellipse. So phone number, there cannot be more than one or more than one. So this phone number, we can say it is simple example for multi-valued attributes. Next one is derived attributes. Derived attributes are normally represented in dotted ellipse. So in this, by the date of birth, we can derive the age. So this age now become as a derived attribute. So by the date of birth, we are going to derive this age. From that, we are going to derive. So this age will become the derived attribute, which is derived from some other attributes. So then it is called as a derived attributes. So derived from other attribute. Relationship. Relationship is used to represent between the entities. So here, what is a relationship? Previously I have explained department and employee. The employee has to work for the department. So here we are going to take teacher is one entity, student is another entity. So these are all the two entities we are having. What is the work of the teacher to the student? The teacher has to teach us. So this teachers is one of the relationship. What is we are going to do for the student? A teacher have to teach. So that is a relationship between a teacher and a student. There will be a student, there will be a teacher. So what is the relationship? The teacher has to teach to the student. So the teachers is the relationship. So there will be types of relationship. In the previous diagram we have seen one-to-one relationship, one-to-many, many-to-one, many-to-many. So these are all the types of relationship. One-to-one means there will be there will be an instance of only one entity relationship between these two entities. So suppose we are going to take female, male. So these are all the two entities. There will be only one relationship, one instance of relationship. So a female can marry only one male, or simply we can take it as male can marry only one female. So there will be an instance of relation is only one. When such type relations exist, then it is called as a one-to-one relationship. Next one is one-to-many. One-to-many means when only one instance of entity of the left and more than one instance of entity on the right associate with the relationship, then it is called as a one-to-many. For example, scientist is one, but he can invent n number of invention. One scientist is not to invent only one invention. He can invent n number of inventions. So there is an association between the entities. One entity is having an associated with n number of relation between the another entity. Then it is called as an one-to-many relationship. Many to one. So there can be n number of instance can be there in left side, but in right side we have only one instance. Suppose we are having this example, we can take student. Student is one entity, course is one entity. What is the relationship? Enroll is n number of students can release one course. Suppose you are taking for the same example for CSE. Suppose there will be for example, if you are taking for 350 students are there in 1 year. So second year I am having. So these students are going to register this particular what we are going to register. We are going to enroll DBMS. All have to register this course. All have to enroll this course. So this is M and this is only one. So this is called as an M to 1, that is many to 1. So this is a many to 1 relation. Many students have to enroll one course. So that is called many to 1. Next one is many to many relationship. Many to many means there will be a n number of instances in the left side, n number of instances in the right side. So there will be association between this one. So n number of employees can be assigned to n number of projects. So not only one employee associated with one project, n number of employees can be assigned to n number of projects. So when this such type of relationship exists, then it is called as a many to many relationship. I think hope you have understand about the relationship, entity, attributes. Next we are going to move on to the degree of relationship. Degree of relationship means number of entity participating in the association or number of entities participate in the relationship. So what number of entity means? There can be one single entity, unary, two entities, we can take it as binary, more than two, it is three entities. If you're participating in a relationship, then it is called as ternary. So unary means only one entity will participate in the relationship. Binary means two entities will participate in the relationship. Ternary means three entities will participate in the relationship. So this is basic of degree of relationship. Next we will see unary. Unary means only one entity will participate in this particular relation. Then it is called as a unary relationship. Next, two entities. If two entities participate in a relation, then it is called, this is a has relation. In a customer has an account. So two entities with one relation, with relationship is called as a binary. This is basically number of, how many number of entities involved in the relationship. That is called as a degree of relationship. So here we are going to consider two. So two entities participate in a relationship is called binary. Next, ternary means there will be three entities participate in a relation, then it is called as a ternary. So employee works in department in this particular location, works in department, works in locations. So this employee department location is three entities which is having a relationship works in. So then it is called as a ternary relationship. Degree of relationship means how many number of entities we are having, or how many number of entities participating in a relationship. That is called as a degree of relationship. Unary, binary, ternary. Unary means one, binary means two entities will participate, ternary means three entities will participate in a relationship. Extended ER model. Extended ER model means we are going to enhance some features in a normal ER model. So we are going to extend. We can say it as extension of ER model. That is called extended ER model or ER model. So there will be two concepts we are going to see in that one. One is three concepts we are going to see: generalization, specialization, and aggregation. By the name itself, we can understand generalization. Generalized means we are going to give the general name for the particular attributes, particular types of attributes or particular number of attributes. Specialization means from the specialized attribute, how we can divide into subtypes. So that is called as a specialization. So first we will see about generalization. Generalization is basically a bottom-up approach. So here you can take the example, current is one of the account type, savings is account type. So these are all combined together to form an account. Our current, savings is an account. Current account, savings account is an account. So these two entities are generalized into common name called account. When employee is there, that employee, whether employee is a current employee or that employee is an ex-employee. So we are going to divide into subtypes. That is called as an specialization. Generalization means you are going to give general name. Specialization means from the common name you are going to divide into subtypes. So that is called as an generalization and specialization. Next, last one is aggregation. Aggregation means there will be not only there is an existence of only one relationship, there can be a two relationship exists between the entities, then it is called as an aggregation. So center is one entity, course is an entity, visitor. What are you going to do? The center offer this course. The center offer this course. This visitor is going to inquire about the offered course in that center. So center is one entity, course in one entity, visitor is one entity. So what is the relationship between the center and the course? Offer. The center is going to offer this course. What is the work of the visitor? The visitor have to enquire. Enquire is another one relationship. So this visitor is going to enquire the offered course in the center. So there will be a two relationship. There will be a two relationship between the entities. Then it is called as an aggregation. So we have seen database design. What is database design? What are the types of database model we are having? Then in that particular we have seen examples. We have elaborately we have seen ER model, ER. Then in that ER we have seen what is entity, what is an attribute, what are the types of attribute, what are the relationship, types of relationship, degree of relationship. Then ER we have seen generalization, specialization, aggregation.
Like, share and subscribe. Hit the bell icon for more updates.